Every night, the scene repeats itself in millions of homes. The plate is empty. The meal was complete. The stomach sends signals that it has received enough food. In theory, that should be the end of the story. But then someone opens the refrigerator, a slice of cake appears, a piece of chocolate appears on the table. The smell of a freshly prepared dessert fills the room. And suddenly, something curious happens. The feeling of being satisfied seems to disappear. How can there be room for dessert if, just seconds before, there seemed to be no room for anything else? For a long time, it was believed that this was simply a lack of discipline, an impulse difficult to control, a simple overindulgence in food. But neuroscience has begun to reveal a much more intriguing story. Perhaps your body isn't really hungry. Perhaps it's your brain responding to a system developed over millions of years of evolution, refined to ensure survival in a world where food was scarce and unpredictable. The problem is that this same system continues to function in an environment completely different from the one for which it was designed. Today, we are surrounded by extremely tasty foods, available 24 hours a day. Images of food appear on social media. Advertisements awaken desires before we even realize it. Artificial aromas are carefully planned to grab our attention, and recipes are created to stimulate specific areas of the brain responsible for reward. In this scenario, eating ceases to be merely a response to the body's needs. It also becomes an emotional, social, and neurological experience. This is precisely where one of the biggest misconceptions about food begins. Not every desire to eat means the body needs energy. In many moments, the decision is not made by the stomach, but by the brain. And the more researchers study this phenomenon, the more they discover that what we call hunger may actually be the result of a sophisticated conversation between hormones, memories, emotions, expectations, and brain reward circuits. The big question is, if the body is already satisfied, why does the brain continue to encourage you to eat? Answering this question means traveling through the history of human evolution, understanding how our ancestors survived in hostile environments, discovering the role of dopamine, unraveling how modern foods manage to capture our attention, and understanding why. Often, resisting food doesn't depend solely on willpower. Throughout this investigation, we will see that the brain isn't trying to sabotage your health. In fact, it's following an extremely ancient program, a program that was essential for keeping our species alive, but which, in today's world, can lead us to make almost automatic food choices without even realizing it. And understanding this mechanism may be one of the most powerful tools for regaining a more conscious relationship with food. Imagine living in a world where no one knew when they would have their next meal. For almost all of human history, this was the reality. Long before agriculture, supermarkets, and delivery apps, finding food was an uncertain activity. Some days there was plenty. On many others, practically nothing. Our ancestors spent hours, sometimes days, walking in search of roots, fruits, seeds, eggs, or small animals. A hunt could end in success, but it could also fail completely. Survival depended on the ability to seize every opportunity to consume energy. It was in this scenario that the human brain began to develop an extraordinary strategy. Whenever a calorie-rich food was found, the brain created an intense sensation of pleasure. This pleasure was not a luxury, it was a survival tool. The greater the satisfaction from consuming an energy-rich food, the greater the chances that person would repeat the behavior in the future. And repeating this behavior meant increasing the chances of surviving and leaving descendants. In other words, the pleasure of eating was carefully constructed by evolution. Not because nature wanted to make us happy, but because it needed to ensure that we sought energy whenever it was available. For hundreds of thousands of years, this system worked almost perfectly. Most natural foods required effort to find. Fruits ripened only at certain times of the year. Honey was rare and difficult to obtain. Meats required long chases or traps. Even high-fat foods, such as nuts, appeared in limited quantities. That is, there was a balance between reward and difficulty. The brain stimulated desire. The environment limited consumption. This balance began to change about 12,000 years ago with the emergence of agriculture. For the first time, human groups began to produce food in a more predictable way. Cereals such as wheat, rice, and corn became the basis of many civilizations. Availability increased, but limitations imposed by seasons, harvests, and storage still existed. Even so, scarcity remained a part of life. Famines caused by droughts, wars, and agricultural diseases were frequent in virtually every region of the planet. The brain continued to live in a world where wasting opportunities to eat was a risk. Then came the Industrial Revolution. From the 19th century onwards, food processing began to transform rapidly. Refined sugar became much more accessible. Flours underwent processes that increased their shelf life and altered their texture. Vegetable oils could be produced on a large scale, but the real change happened in recent decades. The food industry began to use knowledge of chemistry, sensory engineering, and consumer behavior to develop products that are extremely pleasing to the palate. It wasn't enough for food to be nutritious, it needed to be irresistible. Companies invested years studying how to combine sugar, fat, salt, and flavorings in the exact proportions to maximize pleasure during consumption. Researchers in the field of eating behavior describe this balance as a set of characteristics that increases palatability, making certain foods especially difficult to ignore. Interestingly, the brain never evolved to handle this type of stimulus. For millions of years, finding a very sweet fruit was a rare event. Today, a single dessert can concentrate an amount of sugar equivalent to what our ancestors would have taken days to consume. The same happens with fats. In nature, foods naturally rich in fat used to come with fiber, water, or required great effort to obtain. Many modern foods offer a highly concentrated combination of fat and refined carbohydrates, something practically non-existent during most of human evolution. For the ancestral brain, this combination represents a true energy treasure, and that's exactly why it triggers such intense responses. But there's another detail that made the problem even bigger. Our ancestors depended almost exclusively on the body's internal signals to seek food. Today, we are constantly bombarded by external signals. A hamburger advertisement, the smell of bread coming out of the oven, the sound of the packaging being opened, a short video showing melting cheese, a brightly lit shop window, a perfectly produced photograph on social media. Each of these stimuli can activate brain circuits related to the desire to eat, even when the body has no energy need. It's as if the brain receives hundreds of invitations to start a meal every day. And often, it responds automatically. This helps explain an intriguing phenomenon observed by researchers. People may feel like eating just minutes after a full meal simply because they have been exposed to visually appealing food. The stomach remains full, but the brain interprets that opportunity as something too valuable to be wasted. After all, for almost all of human evolution, ignoring a source of energy could mean facing days of scarcity. The brain still carries this programming, but the environment has changed much faster than evolution has been able to keep up. Today, food doesn't need to be sought. It seeks you. It's in the streets, on screens, in colorful packaging, in artificial aromas, in promotions, and even in moments of leisure. This transformation has created a silent conflict between a brain shaped to survive scarcity and a world characterized by permanent abundance. And understanding this conflict is only the first step, because while evolution explains why we like certain foods so much, it still doesn't answer the most intriguing question of all. Why does simply looking at a piece of cake make the brain act as if we're still hungry, even when the body has just said it's had enough? This is where surprising neuroscience discoveries about two completely different types of hunger come in. a distinction that changes how we understand our own eating behavior. You've probably experienced this situation. After a hearty lunch, someone asks, "Do you want dessert?" Moments before, it seemed impossible to eat another piece of anything. But when the dessert appears, something changes. The appetite reappears almost like magic. At first glance, this seems to contradict everything we know about satiety. But neuroscience shows that, in fact, we are confusing two completely different processes. There is hunger that arises from the body's needs, and there is the desire to eat that arises within the brain. This difference is so important that scientists have given them distinct names. The first is known as homeostatic hunger. It has a simple mission to keep the body functioning. When energy reserves decrease, hormones and nerve signals inform the brain that it's time to seek food. After a meal, other hormones communicate that we have received enough energy, naturally reducing the desire to continue eating. It's a system of balance. Without it, it would be impossible to survive. But there is a second system, much more sophisticated, much more powerful, and, at many times, much more influential. It's called hedonic hunger. It doesn't arise because the body needs calories. It arises because the brain identifies an opportunity for reward. This is a difference that completely changes the way we view eating behavior. Imagine you've just left a restaurant. You're completely satisfied. On your way home, you pass a pastry shop. The aroma of sweet bread wafts onto the sidewalk. The cakes are brightly lit in the shop window. The colors catch your eye. Your brain immediately begins to recall memories. Birthdays, family Sundays, happy moments. Before you even realize it, the craving appears. None of this means your body needs energy. What has been activated is not the hunger system, it's the reward system. This mechanism depends on a fascinating characteristic of the brain. It doesn't just react to the food itself, it reacts to the expectations created around that food. In practice, this means that the simple act of imagining a sweet treat can stimulate brain areas related to pleasure. Seeing a photograph, smelling a scent, hearing someone describing a recipe. All of this can trigger a cascade of neural responses before the first bite is even put in your mouth. It's as if the brain is always trying to predict where it will find the next reward. This ability was extremely useful during evolution. Anticipating a feeding opportunity increased the chances of survival. Today, however, it operates in a completely different environment. We have never been exposed to so many food stimuli. We've never seen so many images of food in a single day. We've never smelled so many aromas strategically produced to stimulate our appetite. And the brain responds exactly as it's programmed to respond. But there's another detail that few people know. The brain doesn't always seek food because it desires nourishment. Sometimes it seeks food because it wants to alleviate an emotion. Think of a particularly stressful day, a difficult meeting, an argument, unexpected news. Many people notice an almost immediate increase in their desire to eat. Not necessarily salad, not even fruit. The craving usually focuses on foods high in sugar, fat, or both. Why? Because the brain quickly learns to associate certain foods with feelings of comfort. Each pleasurable experience leaves a kind of record. If, for years, a person eats ice cream while watching a relaxing movie, or chocolate whenever they are sad, the brain begins to create a connection between that food and emotional relief. Over time, the emotion only needs to arise for the craving to appear. It's a learning process, not a character flaw. This explains why two people can react completely differently to the same situation. While one person loses their appetite during stressful times, another feels an almost irresistible urge to eat. Each brain builds its own associations throughout life. Childhood experiences also play an important role. Many families use food as a form of reward. Did you get a good grade? Let's have ice cream. Did you behave well? You can choose dessert. These gestures usually stem from affection, but without realizing it, they help the brain associate food with achievement, comfort, and celebration. Decades later, these connections remain. Another almost invisible aspect is the so-called variety effect. Researchers have observed that the feeling of satiety decreases when we are exposed to different flavors, colors, and textures during the same meal. This is why a buffet usually stimulates greater consumption than a simple dish. Even when the body has already received enough energy, novelty keeps the brain interested. It is also one of the reasons why many people can refuse more rice, but easily accept dessert. Sweets offer a completely different sensory experience. The brain interprets this as a new opportunity for reward. There's even a term researchers use to describe this phenomenon: specific sensory satiety. In simple terms, we become temporarily less interested in continuing to eat the same food, but we can regain our appetite when a different flavor appears. Now think about the modern environment. Meals accompanied by soft drinks, desserts, snacks, sauces, appetizers, everything offering distinct stimuli. The brain rarely gets the chance to say, "That's enough." It's constantly being presented with something new. As if that weren't enough, there's another extremely powerful factor: habit. A large part of our food choices happen without conscious reflection. You grab a cookie while working, you eat popcorn during a movie, you snack while driving. You open the refrigerator at the same time every day. These behaviors can occur even without hunger, because after being repeated countless times, they cease to depend on a conscious decision. They become automatic routines, and the more automatic a behavior becomes, the less we perceive what is happening. This is precisely why so many people believe they lack willpower, when in reality, they are facing brain mechanisms deeply rooted in evolution, emotions, learning, and daily habits. But we still need to understand the main character in this story. There is a substance produced by the brain that participates in practically all of these situations. It appears when we expect a reward, when we find something pleasurable, when we learn new behaviors, and when certain foods completely capture our attention. Its name is dopamine, and understanding how it really works can forever change the way we perceive the desire to eat. For a long time, it was believed that dopamine was simply the pleasure molecule. The idea seemed to make sense. If a food was delicious, the brain released dopamine. Therefore, it should be responsible for the sensation of pleasure. But research in recent decades has revealed a much more interesting story. In reality, dopamine is not pleasure itself. It is much more related to the motivation to seek a reward than to the pleasure of receiving it. This discovery has profoundly changed the neuroscience of eating. Imagine a simple experiment. You enter a bakery and smell freshly baked bread. Before even tasting anything, several areas of the brain begin to increase their activity. You haven't eaten yet. You haven't tasted it. Even so, your brain has already begun a process of anticipation. It is precisely at this moment that dopamine comes into action. It functions as a prediction system. Instead of saying, "That was pleasurable," it seems to ask, "Is it worth pursuing this?" The greater the expectation of reward, the greater the activation of this circuit tends to be. This mechanism was essential for human survival. Imagine a hunter finding a tree laden with the fruit during a period of scarcity. If the brain didn't motivate him to pick as much as possible, that opportunity could be lost. Dopamine helped transform opportunities into actions. The problem is that the modern brain uses the exact same system to respond to completely new stimuli. A pizza advertisement, the glow of a package, the sound of a package being opened, a notification from a delivery app. All these signals can activate reward circuits even before the first bite. And there's another surprising detail. Over time, the brain learns to respond more to the signals than to the food itself. That's why some people crave popcorn as soon as the movie theater lights go out, even after they've had dinner. Or they automatically crave something sweet after lunch. Or they grab a coffee with a cookie without even thinking about it. The brain has created associations. It has learned that certain contexts are usually followed by a reward, so it starts to anticipate it. This is a process known in neuroscience as reward-based learning. This learning is incredibly efficient. Whenever a behavior produces a result considered positive, the brain registers that experience and increases the likelihood of repeating it in the future. This is how we acquire important skills. We learn to drive, to play an instrument, to speak a new language. But the same mechanism also participates in the formation of eating habits. Each repetition strengthens a kind of neural pathway. The more times it is followed, the more automatic it becomes. This is why changing habits is often so difficult. Not because there is something wrong with the person, but because the brain is using exactly the same systems responsible for any form of learning. Meanwhile, another set of mechanisms works silently to inform us when we have eaten enough. The stomach begins to distend. The intestine releases hormones. Adipose tissue sends signals about energy reserves. Among these chemical messengers, two have gained enormous prominence in research: ghrelin and leptin. Ghrelin tends to increase before meals, stimulating appetite. Leptin, produced mainly by adipose tissue, participates in communication with the brain about the availability of energy in the body, contributing to the regulation of satiety in conjunction with various other hormones and metabolic signals. For a long time, it was thought that the mere presence of leptin was enough to make hunger disappear. But reality has proven to be much more complex. The brain does not receive information from just one hormone. It integrates hundreds of signals at the same time. Amount of stored energy, blood glucose level, meal composition, time of day, sleep quality, level of physical activity, emotional state, and past experiences. All of this is processed simultaneously. It's like a huge control center trying to decide which behavior offers the greatest advantage at that moment. In addition to ghrelin and leptin, hormones produced by the intestine, such as GLP-1, PYY, and cholecystokinin, CK, also help reduce appetite after meals by sending information to the brain about the arrival and digestion of food. In recent decades, these mechanisms have received considerable scientific attention precisely because they show that the gut and brain maintain constant communication. This conversation happens in fractions of a second. It occurs through blood circulation, the nervous system, and especially through the vagus nerve, a kind of expressway that connects various organs to the brain. That's why satiety doesn't depend solely on the size of the plate. It depends on the quality of the information reaching the brain. Foods rich in protein and fiber, for example, tend to stimulate these signals more intensely and for longer than highly refined foods, although the response varies between individuals. At the same time, ultra-processed foods often combine characteristics that favor quick and very pleasurable consumption. High energy density, soft texture, intensified flavors, and low chewing requirements. This can make it easier to ingest large quantities before satiety mechanisms fully operate. Another aspect revealed by neuroimaging studies is that different brain regions participate in this process. The hypothalamus acts as a regulator of the body's energy needs. Structures such as the nucleus accumbens, the amygdala, and parts of the prefrontal cortex are involved in the evaluation of rewards, emotions, memories, and decision-making. In ideal situations, these systems work in balance. But factors such as chronic stress, sleep deprivation, and constant exposure to highly palatable foods can alter this balance, increasing the weight of reward circuits on food choices. This doesn't mean the brain is addicted to food in the same sense as with psychoactive substances. While there are similarities in some neural circuits, most researchers recognize that eating behavior is far more complex and cannot be reduced to a single explanation. Science, therefore, points to an important consensus. Eating is not just a response to hunger. It is the result of the integration of biology, learning, emotions, environment, and social context. And perhaps the most important discovery is this: the brain was not designed to easily resist an environment full of intense food stimuli. It was designed to seize survival opportunities. The challenge is that these opportunities, which previously appeared occasionally, are now everywhere. But this raises an inevitable question. If we understand how these mechanisms work, why do so many people continue to feel the urge to eat precisely during moments of greatest stress, in front of the television, browsing social media, or walking through a shopping mall? The answer lies less within the brain than around it, because in the modern world, the environment has become one of the most powerful triggers of eating behavior. Think about how many times you saw food today, not how many times you ate it, how many times you saw it. Perhaps it was an advertisement on your cell phone before you even got out of bed, a photo on social media, the aroma of coffee coming from the corner bakery, a neon sign during your commute to work, a short video showing melting cheese, a promotion sent by a delivery app precisely at the time you usually have lunch. Now compare this to the routine of a human being who lived 10,000 years ago. The difference is striking. For almost all of human evolution, finding food required searching. Today, it simply exists. In many cases, not even that. Food reaches us through screens, sounds, smells, and messages carefully planned to capture our attention. The brain interprets each of these stimuli as a possibility of reward, and this happens even when the body doesn't need more energy. This is one of the biggest transformations in the history of food. Before, hunger initiated the search for food. Today, it is often the presence of food that awakens the desire to eat. This phenomenon has a name in psychology: environmental cue-induced eating. In other words, external signals begin to influence eating behavior independently of physiological need. A simple package on the table can increase the likelihood of someone eating. A bowl of candy within reach is often consumed almost without people realizing it, not because they are hungry, but because the brain responds to what is available. This is why so many food choices seem to happen on autopilot. You walk through the kitchen, open the refrigerator, quickly look at what's inside, close the door. A few minutes later, you return. Nothing has changed. But the simple act of visualizing the food kept those stimuli active in the brain. Now imagine this process repeated dozens of times throughout the day. It's not hard to understand why so many people say, "I wasn't even hungry, but I ended up eating." The modern environment was built to compete for our attention, and food is part of this competition. Supermarkets, for example, don't organize their aisles by chance. More attractive products usually occupy strategic positions. Items near the checkout lines stimulate impulse purchases precisely when a person has already reduced some of their self-control after making numerous decisions during shopping. Packaging also plays an important role. Vibrant colors, high-definition photographs, words like creamy, crunchy, or artisanal. All of this influences expectations even before the first bite. When we expect something to be pleasurable, the brain already begins to prepare its response. Another frequently ignored factor is stress. Our bodies were developed to react quickly to threats. In dangerous situations, hormones like cortisol help mobilize energy to face challenges. The problem is that the brain doesn't differentiate very well between a chase in nature and an inbox full of emails, tight deadlines, or constant financial worries. Modern stress tends to be less intense from a physical point of view, but much more prolonged, and this continuous exposure can influence eating behavior. Some people lose their appetite. Others start seeking more palatable foods. There's no single answer, but many studies show that, in part of the population, stress favors the consumption of foods high in sugar and fat, probably because these foods offer an immediate reward during moments of emotional discomfort. It's as if the brain is saying, if I can't solve the problem now, at least I can find a small feeling of well-being. This relief is usually temporary, But the brain quickly learns this association. The more it is repeated, the more automatic it can become. There is also another silent character in this story: sleep. Just 1 or 2 nights of poor sleep are enough for many people to notice a change in their appetite. This doesn't happen just because we are tired. Sleeping too little alters several signals involved in the regulation of hunger and satiety, in addition to reducing the willingness to make more planned decisions. When we are sleep deprived, the brain tends to value immediate rewards, and few rewards are as quick as a highly palatable food. Perhaps you have already noticed this after a sleepless night. The desire for sweets, salty snacks, and quick bites tends to increase. At the same time, the motivation to prepare a balanced meal often decreases. It's not just a matter of laziness, it's a combination of biological, cognitive, and emotional changes. Emotions also profoundly shape our choices. We celebrate birthdays with cake. We celebrate achievements in restaurants. We share popcorn during a movie. We gather the family around the table on special occasions. Food occupies a central place in human culture. And that's a positive thing. The problem arises when all emotions begin to be regulated by food: joy, anxiety, loneliness, boredom, frustration. If any emotional state always ends up in the kitchen, the brain strengthens this connection. Over time, simply feeling a certain emotion is enough for the desire to appear automatically. Social media has further amplified this effect. We have never been so exposed to images of food prepared to look perfect. The lighting, the framing, the shine, the sound of crunching, the chocolate slowly dripping, everything is designed to capture the brain's attention. Even knowing that it's advertising or entertainment, our reward circuits continue to respond. They didn't evolve in a world of screens. And perhaps there's an even more surprising detail: speed. Most modern foods can be consumed in just a few minutes, some in just a few seconds. When we eat too quickly, the brain receives satiety signals with a certain delay. This means we can ingest a significant amount of food before the body communicates that it has had enough. Chewing less, eating distractedly, having lunch in front of the computer, having dinner while watching television. All of this reduces our perception of the act of eating itself. And when we pay less attention to the meal, we also perceive fewer internal satiety signals. Without realizing it, we begin to rely much more on external stimuli than on the messages sent by our own body. This is why 2 people can eat exactly the same meal and end up with completely different sensations. One eats slowly, talks, perceives the flavors, and naturally identifies the moment when they are satisfied. The other finishes the plate looking at their cell phone almost without registering the experience. The food was the same, but the brain lived 2 completely distinct experiences. The good news is that understanding these mechanisms completely changes the way we deal with them. When we understand that a large part of the desire to eat arises from the interaction between the brain and the environment, we stop seeing everything as a battle of willpower. We've come to realize that small changes in context can produce big differences in behavior. And that's precisely what we'll see next. Because science not only explains why the brain keeps craving food, it also shows practical strategies for working with this system instead of fighting against it. After understanding how the brain makes decisions about food, one conclusion might seem inevitable. So am I doomed to follow these impulses? The answer is no. The same neuroscience that explains why we feel like eating also shows that the brain is extraordinarily adaptable. It learns habits, but it can also learn new habits. It creates associations, but it's also capable of replacing them. This happens thanks to a characteristic called neuroplasticity, the brain's ability to reorganize its connections as we accumulate new experiences. In other words, you don't need to fight the brain. You need to teach it to respond in different ways. And this learning begins with a simple principle: make the choices you want to make easier. For a long time, it was believed that healthy eating depended solely on self-control. Today, we know that the environment exerts a huge influence on our decisions. If highly palatable foods are always visible on the table, it's natural for the brain to be reminded of them repeatedly. On the other hand, when fruits, nuts, or other nutritious foods are more accessible, they are more likely to be chosen. Not because willpower has increased, but because the path to the decision has become easier. This concept is widely used in behavioral science. Small changes in the environment can produce disproportionate changes in behavior over time. Another important step is learning to differentiate between two questions. The first is, am I really hungry? The second is, what triggered this desire to eat? It may seem like a subtle difference, but it completely changes how we interpret our own bodies. Before reaching for food, it's worth pausing for a few seconds. Did the hunger appear gradually or suddenly? Would any food do? Or is there a craving for something very specific? Did I just finish a meal, or has it been several hours? Am I tired, anxious, or just bored? These questions help distinguish physiological hunger from hunger motivated by emotions or environmental stimuli. Answering them won't always be easy, but the simple habit of observing already reduces the likelihood of acting automatically. Another evidence-supported strategy is to slow down during meals. The brain needs time to integrate the signals sent by the stomach, intestines, and satiety-related hormones. When we eat too quickly, these signals arrive late. Not because they are failing, but simply because they haven't had enough time to be processed. Chew calmly. Take small pauses between bites. Avoid swallowing quickly. These simple actions increase the opportunity to notice when satiety begins to emerge. It's also worth paying attention to the composition of meals. Proteins, fiber, and minimally processed foods tend to promote longer-lasting satiety compared to meals composed mainly of refined carbohydrates and ultra-processed foods. This doesn't mean completely eliminating sweets or foods of personal preference, but building a dietary base that keeps the body satisfied for longer. The goal is not to create rigid rules. It's about reducing situations where the brain needs to face intense stimuli right after an unsatisfying meal. Sleep deserves special attention. Often, the first intervention to improve the relationship with food isn't on the plate. It's in the bedroom. Sleeping adequately helps maintain the balance between the systems that regulate hunger, satiety, attention, and decision-making. There's no magic number of hours that works for everyone, but maintaining a consistent sleep routine usually benefits both metabolic health and eating behavior. The same applies to stress. Completely eliminating stress is impossible, but finding other ways to deal with it reduces the need to seek relief exclusively in food. For some people, this means walking for a few minutes. For others, talking to someone they trust. Exercising, listening to music, meditating, reading, breathing deeply for a few moments. The important thing is to expand the repertoire of strategies available to the brain when difficult emotions arise. There is also a practice that is receiving increasing attention in research: mindful eating. Contrary to what many imagine, it doesn't consist of following a specific diet. It consists of paying attention to the act of eating. Noticing aromas, textures, flavors, speed, hunger level before the meal, and satiety level at the end. This practice helps reduce the so-called autopilot, allowing food choices to become more deliberate. It doesn't prevent someone from eating a piece of cake, but it increases the chance that this decision will be conscious and not simply a response to a momentary impulse. Another important point is to abandon the idea of perfection. Many people alternate periods of extremely rigid control with episodes of excess. This cycle often generates frustration and makes it difficult to build sustainable habits. Science shows that gradual changes tend to be more lasting than radical transformations. It's not necessary to get every meal right. What really matters is the pattern built over weeks, months, and years. It's also worth remembering that no single food determines a person's health. An occasional sweet treat doesn't destroy a balanced diet. Similarly, a single nutritious meal doesn't compensate for an unfavorable eating pattern. Health is the result of repetition of small choices made continuously. And perhaps this is the greatest shift in perspective provided by neuroscience. When we understand that the brain responds to signals, habits, and contexts, we stop interpreting each food choice as a test of character. We begin to see it as a behavior influenced by countless factors, many of them modifiable. This doesn't eliminate individual responsibility, but it makes that responsibility more realistic and more human. Instead of relying solely on willpower, we can build environments, routines, and habits that work in our favor. In the end, the goal isn't to win a war against the brain, it's to understand the logic with which it works. Because when we understand this logic, we realize something surprising. The brain has never been trying to sabotage us. It simply continues doing what it has learned to do over millions of years. And this discovery completely changes the way we look at ourselves. At the beginning of this investigation, everything seemed to revolve around a simple question. How is it possible to feel like eating right after finishing a meal? Now the answer appears much more clearly. Most of the time, there is no contradiction between the stomach and the brain. They are simply answering different questions. The body asks, "Do I still need energy?" The brain asks, "Is there a reward opportunity worth taking advantage of?" For millions of years, these two questions almost always went in the same direction. When an energy-rich food appeared, it was smart to take advantage of it. No one knew when the next opportunity would arise. This behavior helped our species survive periods of scarcity, climate change, and challenges that we can barely imagine today. But the world has changed, and it has changed at a speed that evolution simply could not keep up with. Today, food is available at any time. It accompanies us on screens, in the streets, in advertisements, in social gatherings, and even in moments of rest. We no longer need to look for it. Most of the time, it is food that finds our attention. The brain, however, continues to use a program developed for a completely different environment. This means that feeling like eating after being satisfied is not, in itself, a sign of lack of discipline. It is often the result of the interaction between biological mechanisms, memories, emotions, habits, and environmental stimuli. This understanding doesn't absolve us of responsibility for our choices. It serves to make them more conscious. When we know why an impulse appears, we stop interpreting it as a mystery or a personal failing. We begin to recognize it as a signal that can be observed before being followed. And this small pause can make a huge difference. Throughout this documentary, some ideas stood out. The first is that hunger and the desire to eat are not the same thing. The body can be satisfied while the brain continues to respond to the expectation of a reward. The second is that the environment influences our choices much more than we usually imagine. What we see, feel, smell, and repeat daily silently shapes our habits. The third is that the brain is adaptable. Just as it has learned certain behaviors, it can also learn new ways. Small changes repeated over time can alter how we respond to daily stimuli. The fourth is that there is no miracle food or villainous food. What truly matters is the eating pattern, the context, and the relationship built with food throughout life. And perhaps the most important lesson of all is this: knowledge doesn't eliminate impulses, but it transforms how we deal with them. The next time that sudden craving for something sweet arises right after lunch, perhaps you'll pause. Perhaps you'll ask yourself, is my body asking for energy? Or is my brain responding to a habit, an emotion, or an environmental stimulus? This simple question can mark the beginning of a much more conscious relationship with food, not based on guilt, nor on extreme restrictions, but on understanding. Because when we understand how the brain works, we stop fighting against it and start working alongside it. And this usually produces much more consistent results than any promise of a quick fix. Thank you for following this investigation to the end. If any part of this story made you see your eating habits differently, share your experience in the comments. It will be interesting to hear about situations where you perceive the difference between the body's hunger and the desire created by the brain. If this content provided useful information, please like and share the video with anyone else interested in science, nutrition, and evidence-based health. This way, more people will have access to information that helps them make informed decisions, free from myths and extremism. And if you're not yet subscribed to the channel, subscribe to follow future documentaries. Here, each episode investigates a question that seems simple at first glance, but reveals a much deeper story when we look at the science. In the next video, we'll explore another everyday behavior that many people consider normal, but which may hide surprising mechanisms of metabolism and the brain. Because when we understand how our bodies really work, we stop following simplistic explanations and start making choices based on what the best scientific evidence has shown. Until the next documentary.